So we are going to do differentiation on higher uh, variables. So first we'll start with scalar field. So let us first start with differentiability of scalar field. Okay. So before going to differentiability of scalar field, can you quickly define me what is linear transformation? Anybody? What is linear transformation? Must have seen if it satisfies two conditions. Correct? What is that? Let me just write. Let V and W, V2 vector space, is a function T from V to W is said to be linear transformation. If two conditions, what are two conditions? Can somebody tell me? What are two conditions of this? The first one is T of alpha x that will be equal to alpha T of x, where alpha is in R and your x belongs to V. Correct? And what is the second condition? Actually, I should write the first one as T of x plus y, but that is okay. T of x plus y is T of x plus T of y for all x comma y belongs to V. Yeah. So this is your definition of linear transformation. Can you quickly give me one example of linear transformation in scalar field? If I am talking about that, means in scalar field, that means what? Your W will be R. Can you give me an example? Yes. T from R3 to R, you may take as T of x, y, z, that is equal to 3x plus 4y plus 5z. Is this a linear transformation? Correct. अगर यहाँ पे कोई मैंने constant term डाल दिया +1, then this will not be a linear transformation. Correct. And if square cube ऐसा डाला, then also it is not linear transformation. Correct. You just need to check whether these two conditions are satisfied by that. So you can easily do that. Take two values, that is uh, first start with the first one, T of alpha of x y z, find whether it is equal to alpha of T of x y z, and the second one will be T of, take 2 point, first one is x1 y1 z1 plus x2 y2 z2, then try to see whether this is equal to T of x1 y1 z1 plus T of x2 y2 z2. If these two conditions are satisfied by this function, then we'll say this is a linear transformation. Similarly, अगर r की जगह पे r2 हो तो then also it is not a issue. Correct? We are just recalling something. Okay, the first one is linear transformation. Second, yeah, open ball. Can you give me the definition of open ball? Again, in first unit we have done that. Yes, we used to write it as BAR. Correct? What do you mean by BAR? It is set of all x in Rn such that norm of x minus e that is less than r. This is called open ball. अभी अगर r 2 रखा तो ये वो like that it will be. Correct? And what is BAR is called R neighborhood or open ball, whatever you say. R neighborhood of E or open ball of E. open ball at center E, radius R. Correct? Okay. And what is interior point? What is interior point? What do you mean by interior point? Let S is subset of Rn and let E that is equal to E1, E2 up to En belongs to S is said to be interior point of S if there exists a real number R which is positive such that BER is contained in S. What do you mean by this? That means what point E को हम लोग over interior point तभी बोलेंगे if I can find a open ball around that which is completely inside S. So suppose this is my S, correct? If I want to talk about this point, if I want to say this is an interior point, so what I should able to draw a open ball which is completely lying in this S, correct? So that means I can draw it. But if my point is here, can I draw an open ball? Can I draw a open ball such that open ball is completely inside that S? If you remember, हम लोग ने open set define क्या किया था, यही define किया था, correct? A set is said to be open if every point is an interior point. That means what? For every point, I should able to draw a open ball which is completely inside that. Do you agree? You can write it here. If every point of S is an interior point, then S is said to be open set. If you remember, हम लोग ने open set का definition क्या बोला था? यही बोला था कि take any point if I can able to draw a open ball, and this is true for all points, correct? Now we are defining वो point को भी we are defining as interior point. So you must focus that. जो ये है अपना, this will be my interior point for me, correct? You agree? Okay. Now, what do you mean by derivative? In our real cases, derivative का मतलब होता क्या है? Do you remember something? What is the definition of derivative? It was something f of e plus h minus f of e. Oh, I should not e plus h. Yeah, that is okay. Divided by h minus f dash of e. That should go to 0, correct? Or if you don't like this definition, then you have another definition, that is f of x minus f of y upon x minus y minus f dash of e, that should tend to 0, correct? So this was the definition of your differentiability, correct? But what do you mean by that? अगर हम लोग ने इसका दूसरा definition दिया, the meaning of this is f of x minus f of e equal to f dash of e into approximate. If I approximate this as, then this is f dash of e into x minus y. Look at the right hand side. Actually, what I am doing, and if I write f of x, so f of x equal to f of e plus f dash of e into x minus y. That means what am I doing? I am putting my f of x as, I am trying to approximate my function f of x with a linear equation, and this is I'm trying to approximate my function. Correct? This is what my definition of derivative is. Correct? If I try to do graphically, then you'll understand properly. Suppose I have a point here. Correct? If I want to find the derivative of this, that means what I am going to do, I am to first find a tangent. Correct? That means what, I am going to make this line, I have to break into some parts such that I want to approximate this with a line. That is what the main case is. करेक्ट बिकॉज इवन मैंने बताया भी था कि इसका हम लोगों ने प्रूफ निकाला कैसे था बाय यूजिंग डेरिवेटिव का फॉर्मूला टेक 2 पॉइंट्स एंड यू सी दैट यहाँ से डेरिवेटिव का फॉर्मूला दिख ही रहा है, इट इज एफ ऑफ एक्स माइनस एफ ऑफ वाई अपॉन एक्स माइनस वाई. करेक्ट. सो derivative means what, approximation to a linear transformation, that's it, you can understand. Okay, now but here now let us come back to this case. अभी यहाँ पे हम लोग को पता नहीं कि वो डेरिवेटिव का वैल्यू क्या रहेगा. करेक्ट. इन अर्लियर केस सी अगर मैंने इसको थोड़ा अच्छे से लिखा तो ये क्या आएगा, इट विल बी एफ ऑफ ई प्लस एच माइनस एफ ऑफ ई माइनस एच इंटू एफ डैश ऑफ ई अपॉन एच. डू यू अग्री? And that 10 to 0, I'm just multiply and divide by h here. Correct. So what is my condition? My condition is this should be a linear transformation for me. This guy should be a linear transformation for me. Correct. So in higher dimension what will be this? And see, f dash of is a constant for me and this is h, so it is definitely a linear transformation. अभी just बात किया हम लोगों ने कि अगर यहाँ पे देखो इट इज़ 3x, अगर सिर्फ 3x है तो दिस इज़ अ लीनियर ट्रांसफॉर्मेशन. 4y है, दिस इज़ अ लीनियर ट्रांसफॉर्मेशन. 5z, दिस इज़ अ लीनियर ट्रांसफॉर्मेशन. If you take addition, subtraction, anything, then also it is going to be a linear transformation. Correct. So for defining differentiability here, we just require this thing. You just need to find this guy. Correct. That is, in earlier case we wanted to find this guy to say whether function is differentiable or not, but now at the place of this I am going to put a transformation t of h. So now I have to find this t of h to say whether function is differentiable or not. Okay, that means let me just quickly write, we try to obtain a linear transformation t of h instead of f dash of e into h. Correct. And keep in mind that h is a vector here, h is in e plus h करा, so h is not a real number for me. So जो डेरिवेटिव में इधर डिवाइड बाय h है, करेक्ट, दैट विल बी अभी नॉर्म h रहेगा अपने केस में, बिकॉज h इज अ वेक्टर. मेक श्योर you understand that. Okay, so let me finally define total derivative of a scalar field. Of a scalar field, let us see. Let f from s Rn to R. This is R because we are talking about scalar field. Okay, you can write it as B a scalar field. Let E belongs to S be an interior point. Interior point F is said to be differentiable at E if there exists a linear transformation T from Rn to R such that limit h टेंडिंग टू ज़ीरो, सेम थिंग जो अभी जस्ट बात किया हम लोगों ने, यहाँ पे मॉड रहेगा बिकॉज योर राइट हैंड साइड इज आर, सो एफ ऑफ ई प्लस एच माइनस एफ ऑफ ई माइनस टी ऑफ एच डिवाइड बाय what will be that norm h, correct? That should be equal to 0. This is your derivative, this is the definition of derivative. You see, अगर n की जगह पे अगर मैंने 1 रखा तो ये क्या बनेगा, t of h, it will just f dash of e into h. Yeah, and the linear transformation जो t of h आया, the linear transformation t of t, you can say t from Rn to R is called the total derivative. The total derivative of f at e. Okay, and it is denoted by d of f of a, derivative of f of a, correct? Is that clear? Just go through the definition once again. मतलब अभी अपना रूल क्या है, we just need to find a linear transformation f of e plus h minus f of e, this is minus t of h, correct? So I'll just give you a trick to how to use that, how to do that, correct? So let us consider this as e of eh. How to see, how to find, that is the main thing. Take e of eh equal to f of e plus h minus f of e minus t of e upon, sorry, this should be t of h, no? T of h upon norm h. दैट मीन्स व्हाट, जो जिसका लिमिट निकालना था उसको मैंने e of eh बोल दिया. आई एम पुटिंग दिस एज e of eh. So what we will get, we'll get f of e plus h minus f of e minus t of h, that is equal to norm h into e of e comma h. Now try to see what is my f of e plus h, that is equal to f of e plus t of h plus norm of h e of eh, correct? Now can you approximate, can you get the value of t of h from here? That means or from here also it is okay. Their subtraction should be equal to t of h into norm h into something. So norm h तुमको directly दिखेगा क्या है. So you just have to see their linear transformation. We will do some example, then you will see. That means what, यहाँ से can you see that this shows that f of e plus h, इसको हम लोग ने क्या किया, approximate किया to a linear function, to a linear transformation, correct? So जो हम लोग ने ऊपर डेफिनेशन लिखा, that can be also redefined as I should write f of e plus h equal to this, where limit h tending to 0 e of e comma h, that must be 0. So this is one more definition, both are same actually, जो ऊपर लिखा है हम लोग ने, both are equivalent. You may take this is one more definition part, correct? Now let us put some remark. Okay, try to see जो derivative है वो क्या है अपना. The first one is derivative f of a. What is my derivative f of a? This is the linear transformation, correct? So you remember this thing is a linear transformation and not a real number, huh? Perfect. What is the second thing? When will be a real number? If we talk about it as in R, then also d of f of a, this will be a real number multiplied by some h. And you can also put epsilon delta definition. What is epsilon delta definition? जो हम लोग पहले यूज करते थे. Let us write that also. So क्या लिखोगे? We'll start with let E belongs to S be interior point. What next? F is said to be differentiable at E if there exists a linear transformation T from Rn to R such that for all epsilon positive, पहले वाला case, there should exist a delta positive. For all epsilon positive, there should exist a delta positive such that norm of h that is less than delta imply mod of f of e plus h minus f of e minus t of h upon norm h. That should be less than epsilon. Perfect. This is the definition. Sorry, it should be mod. ये mod है. So this is your epsilon delta definition. Correct. Now let us solve. अगर f differentiable हर एक point के लिए, then we'll say f is a differentiable scalar field. That is okay. So let us start with the simplest example by taking. Let us take f from R2 to R given by f of xy is equal to 3x. So this is my function. I want to find. I want to check whether this function is differentiable or not. Correct. So how will you do? The first thing is अपने को a decide करना होगा. So let us take e equal to e1 e2 since it is in R2, and what is my h? H will be h1 h2. So let us find f of e plus h. What is f of a plus h? That is f of e1 plus h1 e2 plus h2. So see, this is the step you have to do in every question. Okay. And what is they are given? F of xy equal to, it is 3 times x. That means it will be 3 times e1 plus h. That means what? 3 e1 plus 3h. Correct. H1, I'm sorry, should be h1. And what is f of e? F of e will be, e is this point, it will be 3e, 3e1. You just need to make sure that this is f of e1 e2, that is equal to 3e1. Now what is their subtraction? F of e plus h minus f of e. What is their subtraction? Yes, it is 3e1 plus 3h1 minus 3e1. That is giving me what? 3h1. So do you see a linear function in terms of h? Do you see a linear transformation in terms of h? अपने को यही चाहिए ना, f of e plus minus f of e plus h minus f of h, that should be equal to, in terms of h I want something, correct? Or look at here, what I want, f of e plus h minus f of a, I want something in terms of h plus something norm h. Norm h तो इधर है ही नहीं, I don't have norm h, so I can choose this guy. So that is the main step. Define t of h that is equal to t of h1 h2 that equal to 3h1. Correct. Now you need to check whether this is a linear transformation. That is easy to see because हम लोग ने just scalar multiple of h1 लिया, so that is a linear transformation. Correct. Can you quickly verify this is a linear transformation? Take two values h1 h2 or p1 p2 ले लो and try to see whether it is a linear transformation. Correct. Once it is linear transformation, what is the next thing you have to do? You have to go through the definition. What is definition? Yes. How will you start? You are having a linear transformation. Let us start. For given epsilon positive, and if you are having to find delta, that is to find delta positive such that mod of h that must be less than delta. What should you have? You should have what? F of e plus h minus f of e minus h na minus t of h upon norm h. That should go that should be less than epsilon. This is what you want to prove. So let us do consideration part. Consider consider norm of f of e plus h minus f of e minus t of h and divide by what? Norm h. Correct? What do you get here? What is f of e plus h minus f? Let us substitute everything. You are getting this as 0. 0, that is already less than epsilon. So this is true for every epsilon. So मुझे delta choose करने की ज़रूरत ही नहीं. I'm getting this as a 0. Do you agree? Hence, what is my conclusion? This is 0 less than epsilon मत समझना. Since this is 0, that means epsilon was my positive. So I can consider this guy as this whole term is less than epsilon. ऐसा. Correct? So what is my consider? Hence, f of xy is differentiable at which point? E1, E2. And what is the derivative? df of e at h, that is equal to df of e at h1 h2, that is equal to what? T of h1 h2, that is equal to 3h1. Is that okay? So this is my derivative. So what can I say? The function is differentiable.